Hey guys. So I thought I would have this done much earlier. I thought when I said I'd have this finished at 3 to 4 today, it would be 3 to 4 in the afternoon, not 3 to 4 in the morning. But here goes. The project we're going to work on until the break is Windmill Project. Is this Windmill Project? And so I've created an overview. I'm going to run through it real quick with you because I won't be in class tomorrow, and then we will talk about it more. If you have any questions, you can always reach out to me. But for now, let me give you a brief overview of what we're going to do. So, you can work in a team. Those groups can be up from 1 to 3 students, but everyone has to turn in their own work. You'll have the same data, you'll have the same design, you may have the same information, but you're going to present it in your own way. I don't want to see any copying between people. Everyone's going to turn in their own document. Okay. And if you work in a team, you will rate each other members' performance. So make sure you choose people that you know you're going to be able to work with. Okay. Um, and then once you have your team, develop a company name and logo and be a little creative. For instance, Vineyard Wind is creating the offshore wind site off of Martha's Vineyard. So come up with a name for your company and, if you're feeling creative, a logo. And then we want to talk about how the physics that we've learned so far this year applies to wind power, or specifically, how does F equals ma apply to wind power? And I'm going to give a brief overview of this right now. You may need to research it more on your own or come and find me during a tutorial for more information. But basically, we know that the force in this case is the force of wind, is equal to mass times acceleration. So that means that the mass of my turbine times the acceleration that it's spinning at is going to be equal to the force of the wind pushing it. So I can't do anything about the force of the wind. The wind is locked. Okay, the wind is whatever it's going to be blowing at. If I make a bigger fan blade, I can grab more of that wind and kind of increase the force acting on my turbine. But if I make the fan blades bigger, well, that makes them heavier. The mass goes up. And if the mass goes up, the acceleration has to go down. I can make smaller blades with a lower mass, and that would make the acceleration go up, but I'd also be harnessing less of the force. So what happens is you end up walking a very delicate balance. I've lost myself in my slides. So the wind speed is locked. A bigger blade catches more air and increases force, but it has a higher mass. The faster the rotor spins, the more energy is converted. Acceleration is increased when the force is increased or when mass is decreased. You're making a delicate balance, though. This whole thing is finding the right balance between the size of the blade and the acceleration that it's going to spin at. Make it too small, it won't catch enough wind, it won't spin fast enough to generate electricity. Make it too big and it's too heavy and it won't spin fast enough. So bigger blades are also more expensive. So they generate more electricity, but they're more expensive. So anyway, that's our problem that we're trying to solve here. And the other half of that is how does the wind become electricity? I know that I have wind blowing, and I know that it turns a rotor on this windmill, but how does that turn my light on in my house? What happens between these 2 points where these question marks are? How does the energy go from mechanical wind energy to mechanical rotor energy to electrical energy? What happens along the way? Once you've solved those problems and you're familiar with that science, you're going to create a wind turbine in your group. And so before you visit the website, you need to decide on your turbine. Use the tables on the next slide to choose what design will work best for your team. And I want you to choose them off this list. I don't want you to choose them from the website because I want you to come up with a plan as to why you're choosing what you're choosing. And on the website, it becomes too easy to just click and try and click and try and click and try until you get what you're looking for. And also, don't choose a location yet. We're going to build your turbine and then try it in each of the 3 locations to see where it works best. So here we have all the design choices: the blade length, the pitch, the twist, the shape, the airfoil shape, and then a definition of what that means and the choices that are available to you. Again, ignore location. But for these other ones, determine which ones you think would make the best turbine, and then choose which things you think are best and make a record of them. Down here are the 3M materials. These are extra materials that you can add to your device, and it will add to the price, but will oftentimes also increase its reliability because it might make it stronger, or it might reduce maintenance. So while the initial price is higher, it reduces the amount of upkeep that has to be done to the machine. So you can read what each one of these does, and you can decide which ones you think might be helpful in your design, if any. Then plan your experiment. And so once you have your design created, we need to develop your experiment. We'll try out your turbine in open plains, on hills, and offshore to find out where it functions best. So name your variables. The independent variable is the thing I change in each trial. What am I going to be changing in each trial of this experiment? And the dependent variable is the thing that I'm going to measure once the experiment's finished. So what will I be measuring as I change each one of these trials? And then constants are all the things that are going to remain the same. What's going to be the same in each trial that I do? I'm going to do 3 trials, right? I'm going to change one thing in each trial. That's going to be the independent. The dependent is going to be what I measure, and the constants are going to be the things that remain the same. So then you're going to make a hypothesis. Where do you think the turbine you built will function best? Do you think that your turbine is going to function best in Jeremith Hill, the highest point in Rhode Island, also a popular hiking and wildlife destination in Foster, Rhode Island, that's out on the left-hand side of the map, or out on the west side of Rhode Island? Would it be best in the flat plains around 2nd and 3rd beaches in Newport, Rhode Island? How would that affect things to have a couple of wind turbines out right along the beach? Or would it be best offshore at the entrance to the bay? Defend your hypothesis with evidence. Why do you think this is the correct place to put it? Feel free to do some research online. Or if you go to the website, it will have a little description around each location to tell you what kinds of things to expect from that location. But make a hypothesis, and don't be afraid to make a hypothesis. It's okay to make a hypothesis and have it come out wrong. That's totally okay. So you're going to run the experiment. Use the simulator located at this link to determine how well your turbine works in each location. Make sure that you click the export data button once you've finished all 3 trials, and your results should look like this. You're going to want all this information. You'll want one in the plains, one in the hills, and one offshore. Notice that everything from blade length to WPA should be the same for every trial, and the stuff at the bottom should be different. To analyze your data, open the spreadsheet that's attached to this link and make a copy of it. Add your chosen features here. All the pieces of your blades. What did you make them into? Like what length did you choose? What pitch did you take? Over here, input the data that you gathered for your plains, hills, and offshore data information. Now, this information is going to be the same for every team member, okay? And that's where it's going to stop, okay? Over here, this box will fill in with information automatically. So on the spreadsheet, you're going to see this box of calculations. And right here, you just see all these error messages. But once you put data into this turbine performance section, it's going to automatically fill in these values with numbers, and you'll be able to see things like how many watts of energy are possible in that machine. How does my efficiency affect the amount of energy produced? How much energy can I create in a year, and how much can I sell that energy for? How much money can I expect to make? How much will it cost? How many turbines do I need to power 2,000 homes? All kinds of information in here that you can pull apart by looking at the explanations and analyzing that information. Again, we can do this in class together later. Finally, you're going to decide which plan is best. Consider the financial gains, the environmental disruptions, the societal impacts of your plan when you're deciding how are people going to respond to, upwards of a dozen windmills in a certain area. What's that going to do to the environment if we do that near the beach? Or what is that going to do to shipping lanes if we do it offshore? There's all kinds of ways to think about how this can impact the area when we build it. Defend your decision with evidence from your experiment. And I want you to include at least one graph and one table from that spreadsheet in your response, which means you're going to have to make a graph. Maybe you make a graph of the number of houses you can power. Maybe you make a graph of the watts produced in each location. Maybe you make a graph of the amount of money you could make in each location. Maybe you make more than one. But find some way to give me a graph and a table, okay? Every person is responsible for making their own graph and for turning in their own work. You don't have to make the same kind of graph as your partners. If this person wants to graph the number of houses they can power and you'd rather graph how much money they can make, great. You should all make your own graphs from scratch. So what you're going to turn in is a presentation about this lab, and you can use any software you want. Google Slides we all know how to use. Prezi is kind of fun. Canva and Visme are two unique ones I found online you can use. Zoho Show had said that it was good for working across different countries because it can easily translate information from one language to another. So it has language support for multiple languages. Or anything else. Just be creative. You want to make some kind of video or something? Whatever you want, as long as you can get all of the following information to me. So include in your presentation all of these things, all right? How do physics concepts apply? So that F equals ma and the flow of energy, you're going to describe that in your presentation. Explain the design you chose. Why did you make those choices? Explain the experiment. What are we going to do? What are the variables? What is your hypothesis? How are we going to come to some kind of a conclusion? You're going to talk about your data. Give me a summary of your data. Is there anything that stands out to you? Was there anything surprising? Maybe you needed more. Maybe this responded in a different environment than you anticipated. Maybe it was better in the hills and you thought it was going to be better offshore. Maybe it pays off to have more smaller windmills than big ones that produce a lot of energy that are more expensive. I don't know. Take a look at your data and see what pops out to you. Include at least one graph and one table in this data section. And then create a sales pitch for your project. Where will it be? What will it look like? What impacts will it have on the wilderness, people, and environment? I can't read what I wrote behind my thing. How much money are we going to make? Right? And I can't see what that last piece says. Oh, defend your decisions with evidence. Any of these decisions you make need to be defended with evidence. You can't just say something. You can't just be like, we're going to make mad bank on this. You have to show me how much money we're going to make and tell me how you know that. And that's what the slideshow and the spreadsheet are for. So I'm going to share this. I'm going to share the spreadsheet. And as a matter of fact, let me show you the spreadsheet right now. This is the wind turbine calculations. So your turbine features you input over here directly from the printout you get, the export data. Directly off of that, you put this information in. And then the planes, the hills, and the offshore, you put in your results from each one of those tests. And as you do that, these pieces below will fill in. As I fill these in with ones, you can see that this automatically fills in with data below to tell me how much money I would make. Okay, so don't worry about those error signs. Now it's far too late for me to be up. I am going to put all this on. Remember that you don't need to come to my class tomorrow. I'm going to put this assignment and an attendance question online. Answer the attendance question and make sure that you are counted as having been here. And I'm going to call it a finished project. Good night.